In this video, we look at a couple more examples from section 1.8 on limits and look at just a variety of examples that can show up in the Wiley Plus homework. Okay. For example, we've got one to the left of the screen that you're seeing here. We've got a limit as t goes to let's say we're going to take the limit as t goes to 2 of the function 2t squared. Notice that this is of the form limit as t goes to some point of interest a of some function f of t. So the point of interest is 2 and the function f of t is equal to 2t squared. Okay, and if we're going to try to tackle this problem and figure out what the implied question was, if they just write a limit, there's an implied question to find what that limit is. Okay, there is the limit process. The limit is a process, and what we can need to do is to choose a delta, we'll say delta t. Okay, and if we choose delta t is equal to 0.5, then we need to take our point of interest, a minus delta t, which is 2 minus 0.5, which is 1.5, and evaluate the function at 1.5. And we can see on the screen here that the value of our function at 1.5 is 4.5. Okay. All right, so what we're doing here is computing a table of values, right? And the point that we're interested in is the time 2, and we looked at, let's say 1.5, okay, and we found the function was 4.5. Change the time spacing, change to a smaller delta t, change to delta t is, say, 0.1. Let's put 0.1 here. And all this stuff you can do on your calculator. Okay. And let's increase the time until we find 2 in the table. So I'm going to keep increasing until I find the point of interest 2. Okay. And then when you choose delta t is equal to, say, 0.1, okay, that means that a minus delta t is 1.9, and so we're going to put 1.9 in the table and look at the value of the function at 1.9, and that is 7.2, I think it was, correct? No, 7.22. Okay, and now we need to continue this process, right? For just using your calculator, that if you have the function, right, you put this into your calculator, for example, 2 times t squared, okay, and we want the point of interest 2, and we want delta t to, say, be 0.001, right, and find the value of the function at 0.001, and you get, okay, evaluate the function at 1.99, so you get 7.992. And then the limit process, okay, by taking what I call the limit leap, we can see that we think that the function is getting closer and closer to 8. Let's try that. Take delta t to be 0.0001. Plug that into the function, you get 7.99992. So by the limit leap, we think that this limit is equal to 8. Okay? And technically we need to be very correct here that what we've done, notice that we have chosen numbers with this little minus sign, numbers from the left. So I'm very assured of saying that the limit as t goes to 2 from the left of this function f of t is equal to 8. Okay? What we need to try to do now is to look at numbers from the right. Okay, which means that we need numbers like 2.001 and 2.1 and 2.5. Okay, and take numbers from the right of 2. Okay, so now if we go back and just put 2 plus like 0.5, you will get that the function is 12.5. If you take 2 plus 0.1, you get 8.82. And if you take 2.001, you get 8.008. And so we can see that the limit as t goes to 2 from the right of this function is equal to 8 also. And because those two limits are the same, we're going to say that the limit as t goes to 2 of this function is also equal to 8. Okay? So there's one quick example on using the table of values to evaluate, using a table of values to evaluate a limit. Okay? And we'll look in another video on another method using graphical techniques.